Hello everyone. It's going to be a video on implementing a linked list in JavaScript. It's going to be a singly linked list. I'm going to already assume that you know what a linked list is and you have some basic JavaScript knowledge already. Just a quick refresher, a linked list is just a list of some data where each element in the list is called a node, and a node has two properties. It has a data value and it has a pointer to the next node. So an example linked list might look like this. So the first node would be 10. Let's just have a list of numbers. And you can see that each node is pointing to the next node. And then so the last node in the linked list, it points to null. So null represents the end of the list. And just one other thing, the first node of the linked list is known as the head node. And so a linked list basically just has one property that you can access, and that's the head node. And so because every node has a pointer to the next node, we can just use the head node to traverse the whole list because we can just keep going to the next node. So that's basically what I'm going to be going over. I'm going to be going over a few methods. So I'm going to be going over isEmpty, which checks if a node is empty. Sorry, a list is empty. We're going to have a method for size, which gives us the amount of nodes in a list. We'll have prepend, which adds a node to the beginning of the list. We'll have append, which adds a node to the end of the list. We'll have a remove method, and there's a few ways you could do a remove method. You could either remove by its index or maybe remove by its value. So for this example, we're going to be removing by value. So if we say remove 10, it should remove um, 10 from the list. So whichever node has a value of 10. And we'll have a contains method, which lets you check if the list has a certain value inside it. And lastly, we'll have a print method, which is like prints the current list in a nice format. So these are the 7 methods we'll be going over. Alright, so let's get started. So I'm going to start off with a constructor function for our linked list. So, like I said, I'm going to assume you already know some basic JavaScript knowledge. So with a constructor function, it's basically going to let us create a list from it. So we'll be able to do something like var list equals new linked list. And whatever methods we have attached to the linked list, we'll be able to use with anything we create using the new operator. Now, there's a couple of ways we can add a method to this linked list. So, for example, if we want to create a method called sayHi, we could just put it inside this constructor and just say this.sayHi equals function and just print out hi. So now if we did list.sayHi, we can see that it prints out hi. So this is one way we can add a method to the constructor function. The other way is to, instead of doing it like that, we can just we can just add it to the prototype of the function. So we can do linked list dot prototype dot sayHi equals function. That should be semicolon. Just same thing, console.log hi, and we can say we're doing the same thing, but it still works. So you might be wondering, which way should we do it? Should we do it inside the constructor using this, or should we add it to the prototype? So convention is normally to put it on the prototype, and I'll show you why. So let's say we wanted to create more than one list. We want to create, let's say 3 lists. We'll have list 2, list 3. So we're creating 3 linked lists. Now, if we didn't do it on the prototype, if we just put it in the constructor like this dot say hi equals. So if we did it like this, every time we create a new linked list, it would be constructing its own say hi function. So each one of these would have their own say hi function in memory. So obviously this isn't the most efficient way. We don't want to keep creating a function over and over every time we create a new list. So this is why prototypes are handy. When you add a function to the prototype, this prototype is just one object and it's shared by every instance of the linked list. So no matter how many lists we create, this is just going to be one object The prototype is just going to be one object that has a function attached to it, and it'll be the same thing. So we'll still be able to access some in each one of the lists, but it's going to be more efficient. So for the purposes of this example, I'm going to be adding all the methods to the prototype. Just one caveat though, when you use the prototype, you lose the ability to create private variables like you would be able to if you did it over here. So we're sacrificing that for efficiency. So that's generally how it's done. But yeah, you could just put all the methods in here as you want, but I'm just going to be doing it on a prototype in this example. So let me get rid of all that. So I guess we'll start off with the isEmpty method. So actually before that, so like I said, the linked list only has one property known to it, and that's the head node. So we'll say this.head, and we'll initialize it to null at first because the list is empty. So let's create the isEmpty method, which checks if a list has no nodes in it. So we'll say linked list dot prototype dot isEmpty equals function. So we know that if a linked list is empty, this dot head is pointing to null. So all we have to do for this function is check if head is null. If it is, that means the list is empty, or otherwise it's false. So we can say if this dot head is null, that means that the list is empty, so we can return true. Otherwise, we can just return false. Now we can shorten this code up by just saying return this.head equals null, and it'll be the same thing. So we can get rid of this. Now let's create a method to check the size of a list. So this is where we're going to be doing our first traversing of the list. So let's say we have an example list here, 10. Let's say we have a list with 3 nodes, and the last node points to null. So the way we want to count how many nodes are in this list, we want to start off a variable count at 0, and we'll start off at this.head, and we're just going to keep traversing the list until we get to the end, and every time we go to the next node, we'll increment the count. So it's pretty straightforward. So the thing is, when you traverse a list, we would have to do this.head.next to get to the next node. So, but the thing is, you don't want to change the value of this.head, because if you do, we lose the ability to traverse the list again. So what we want to do is create a temporary variable that we'll be using to traverse. That way, the next time we want to traverse, we can just use this.head again, and it'll work fine. So let's create a temporary variable called current, which will point to the current node. We'll start off at null. We'll just start off at this.head. And now we can just keep doing current equals current.next to get to the next node every time. And we'll also start off a count variable at 0. So we'll say while current. So how do we know that we've reached the end of the list? We want to keep looping, keep going to the next node until we reach the end. So like we mentioned previously, null means that we're at the end of the list. So once we get to null, we know that we're at the end. So we can say while current isn't null, run this code. So all we want to do is increment the count and then move on to the next node. So we can say current equals current.next. So current is going to go to the next node. And then at the very end, we just return the count. And that's pretty much all we have to do for our size function. So now let's go on to the prepend, which is going to add a node to the beginning of the list. So prepend is going to take in some value. So it's going to take in some value, whatever value you want to add to the beginning of the list. So let me create another example list. So let's say we have a list with 3 numbers again. That should point to null. So let's say we want to add 5 to the beginning of the list. So there's a couple of steps to this, and we know that this.head is pointing to this 10 right here, because that's the first node, right? So there's a few steps that we're going to have to do. First, we're going to have to create a new node with 5 in it. So first, create a new node with whatever value we pass in. Second, we need to make this new node point to the current head. That way that, so we basically create this new node. We want to make it point to the current head, so it'll be pointing here. And then lastly, we want to move this to head from 10 to 5 because this to head is pointing to 10 right now because that was the head node. So just creating the node and pointing to this isn't enough. We have to move this to head to be pointing to that new node we created. So make the new node point to the current head, and then we have to update this head to point to the new node. So let's do these 3 steps. So first, let's create a new node using the val. So creating an object is pretty easy in JavaScript. We can just say new node equals, and then we want, so remember a node has 2 properties. It has some data inside it and it has a pointer to the next node. So for data, we'll just use val as the data. And our next node, remember we said that we want this new node to be pointing to the previous head. So we can just say next this head. And now we just need to update this head to point to this new node. So that's easy. We can just do this head equals new node. And that's actually all we have to do for the prepend method. So why don't we try it out? Let me create a new list. So let's do list.prepend 10. Okay. Obviously I need to print it out later. Go away. Okay, so the format's not going to be that nice, but you'll be able to see that we have a linked list object. Its head is pointing to this object right here. This is the node object we created. We can see that the data is 10, the next is null. So if we prepend one more thing now, so now our list should look something like this. Because we inserted 10 first into an empty list, and then we prepended 5. Prepend adds it in the front, so this is what our list should look like this. So let me just comment that out so we can run this. So yeah, like I said, the format won't be nice. We're going to be creating a print method later on, which will make it nicer. But so you can see that head is pointing to this node right here. So this node that's highlighted, its data value is 5, and its next value is the second node that we created, which was the one with 10. So the second node is the next node of that this node. So that might be a bit confusing. So let's just focus on the code right now, and then we'll see. It'll be easier to see once we create our print method. So let's just also try out our other methods we made. So we can do list.size. You can see 2 prints out because we added 2 elements to our list, and we'll just say list.isEmpty. This should obviously print out false, and it does. Cool. So we finished these 3 methods. Now let's go on to our append method, which adds a node to the end of the list instead of the front. So with this method, it's going to be kind of like our size method. So it's going to take an val and add it to the end. So like our size method, we want to keep traversing our list till we get to the last node, and then add it to the very end. So once we get to that last node, we need to make that last node's next value change from null to the last node, to the new node. So here's the steps for creating, for adding a node to the end of the list. Create a new node using val. And then, so once we create the new node, we want to traverse to the end of the list. And then once we get to the last node, make the last node's next value point to the new node. And that's all we need to do. So the first thing we can do is check if the list is empty, because if the list is empty, we don't have to do any traversing. We can just make this.head point to this new node, because there's only going to be one node in the list. So we can say if this.is is empty, so we're using that isEmpty method we created up here. If this.is is empty, this.head equals val. Sorry, we have to create the node first. Equals new node, and now let's create new node. So its data is going to be val, and because this is going to be, we're adding it to the very end, we want its next value to be null, because the last node in the list should be pointing to null. Okay, so if this is empty, just make this.head point to this, and then we can just return out of this function. Otherwise, we're going to start, remember how we created a current variable, start at this.head, and we're going to do something slightly different. We're not going to do while current is not equal to null. We're actually going to stop one place before that, because we don't want to go all the way to null. We want to stop at the very last node. So we can say while current dot next is not equal to null. That way, instead of making current go actually point to null, we're going to stop at the node that points to null, and then we'll make that node point to this new node. So we can say current equals current.next. So keep going to the next node until we get to the node that's pointing to null, which is the last node. And then, so current is pointing to the last node now after this loop, and we can just say current.next equals new node. And we're good. So let's just test this out as well. Create a new list. So let me append 10. I just realized we didn't create the print method, so maybe I should just hold off on that. And then, so let's just go on to the next method, which I believe was remove. And I'll show you at the end, once I get to the end, yeah, I'll show you all the using all these different methods, and then we can hopefully, yeah, I don't think I made any errors, but yeah, let's just wait till the very end to test them all out. So remove is going to be similar. We take in a value. So with our remove method, there's two cases we need to account for. So if the node to be removed is the head node, all we have to do is make this.head point to the next node. So this.head will switch from the current head to the next node of the head. That way, nothing's going to be pointing to that first node anymore, which means it'll get deleted. So the second case is where the node to be removed is somewhere else. So let's say, let me make another example list. So let's say we wanted to remove 5. So like I said, we just, so currently this.head is pointing to this 5, right? So all we need to do is move head from pointing to this and just move it here. And so nothing is pointing to this, so it'll just get removed automatically. So let's just work on that case first. If this.head.val equals val, or actually before we even check for that, we should check to make sure that the value to be removed is actually even in the list. So if they're trying to remove a value that's not even in the list, we can just exit out right away. So that's why we created our contains method. Well, we didn't create it yet, but that's what we're going to be using. So how about I just create the contains method first, actually. So we can do linked list.prototype. So it takes in a value, and it checks if a value is in there. So it's going to be like the size method. We're going to go all the way to null. And if we actually encounter this value, we'll return true. Otherwise, we'll just return false. So we'll start off at the very beginning. Close this head. So while current is not equal to null. So if current.val equals val, we'll return true. Otherwise, we'll go on to the next node. So if we get through this entire while loop and we still haven't returned true, then we'll just return false, which means it's not in the list. So now we can use this contains method. So we can say if this does not contain the value, we can just return. There's nothing to do then. Otherwise, we're going to check if this .head is the node to be removed. So if this .head .data equals val, all we need to do is move this .head to the next node. So we can just say this .head equals this .head .next and just return. Otherwise, that means the node is not the first node, in which case we're going to have to do something a bit different. So we have to make sure, so the way we're going to do it is, so let's say we wanted to remove 15 in this list. Wait, let me just make a bigger list, it might be better to see. So let's say we wanted to remove 15. So we're going to have another pointer. We're going to start off at 5, but we'll actually have 2 pointers now. We'll have a previous for current, and we'll have a pointer for the previous. So we're going to keep moving current, and we're going to keep moving previous one node behind it. So current and previous are both going to start off at 5. And then what we'll do is only move current. And then, so we're going to keep traversing these one at a time. So current is going to go to 15 and previous is going to go to 10. Sorry. And then we're going to traverse again. And we're going to keep doing this until current is pointing to the node we want to be removed. So the reason we want to keep this previous pointer is so we want to remove 15, right? Now that current is pointing to 15, we have this previous node pointing to 10. So what we can do is just set previous is next. Instead of making it point to 15, we're going to make the pointer go around and make it just point to 20. So we can just remove this pointer here and make it point to 20 instead. So we're going to be making making 10 just point to 20, and then nothing will be pointing to 15, so it'll be removed. So this is what we're going to end up with. So let's do that. We'll start off previous at null and start current at this .head. So we'll say while current data is not equal to val, we'll say, so we'll move previous to point to what current is currently pointing to, and we'll make cur point to cur.next. And now all we have to do after that is make the previous .next point to current.next, because right now previous.next is pointing to current. So all we need to do is make it point one node past that. So we'll just say previous.next equals cur.next. So nothing will be pointing to cur anymore, and it'll get removed. Okay, so that's it for the remove method. Now I think all we need to do is create a print method, which will print all of these out. So that's going to be easy also. It's kind of just another traversal, and so let me just get right into that. Dot prototype dot print equals function. So when I print the list, I kind of want the output to look like this. So if we have a list with 5, 10, 15, 20, I want the output to just look like this. So let's start off output and start off as just a opening brace. And so we'll have a current node so that we can traverse the list. And we'll just say while current is not equal to null, we'll say output plus equals current.data. So we'll add on each value to this output one at a time. And we can just add a comma if there is a next value. So we can say if current.next is not null, So if there's still more things after it, let's just add a comma. Output plus equals comma. And, oh, sorry, typo. And then at the very end, once we've looped through each one of these, let's just add the closing brace. And we just return the output now. And okay, I think we're done then. Let's see. So why don't we try all of these methods out and see if I failed miserably somewhere. We'll do var list equals new linked list. So let me just see what happens if we print without anything. Should return, um, oh sorry, instead of returning we should print it out. So this should print out empty braces. Okay, cool. So why don't I add some stuff? Let's that, not add, it should be append. 15, 20. And of course you can just append anything. I'm just doing numbers to keep it simple. Okay, so, okay, looks like we got into an infinite loop. Of course, because we're not moving on to the next node here. So after we've added the data, we should move on to the next node. Otherwise, we're just going to keep doing that. Okay, now let's try it out now. All right, looks like we got the, let me just add a space to keep it a bit neater. So this looks good. Let's try prepend now. Let's dot prepend 5. So 5 should go to the very front. Cool. And let's just try some of the other methods. Let's print out if the list contains, let's see if it contains 10. False. Let's see if it contains, wait, it's false. Contains, let me see, contains. So if current dot, oh, it should be current dot data. Okay, it's true now. Okay. And so contains 10, that's true. Let's see if it contains 7. It should not. That should be false. Good. Let's see. Let's print out the size of the list. 5 elements inside it, which is correct. And yeah, I think that's all the methods. I guess we can just try is empty. Let me just get rid of all this other stuff. False, which is obviously true. And yeah, so that's a very basic implementation of a syncly linked list in JavaScript. Let me know what you thought. If I could have, if I went too fast, maybe, or if you have any questions, feel free to leave something in the comments. Thanks for watching.